Hello, everyone, and welcome to Arduino for Artists, the session today. We are super chuffed to have Nye Thompson and Michele Panegrossi here today to talk to us about Arduino and some of the ways that they've been using it in their work. Nye is a visual artist. And Michele is a creative technologist, but I'm going to ask them to tell us in a very kind of brief 1 minute what that means and what they do. So Nye, if you kick us off and tell us a little bit about yourself.
Hi there, it's lovely to be here and to meet you all. So my name is Nye Thompson and I'm an artist based in London, and I work in the sort of media art, digital art space, particularly in sort of moving image. But I also create experimental software systems. Is perhaps experimental software architectures is a good way to describe them. I'm very interested in systems, and I'm also very interested in the idea of machine gaze. I've been working with Arduino for I think probably about 6 years. So I'm going to tell you a little bit about my sort of trajectory through that and my journey with that sort of technology.
Hi, my name is Michele, and I work as a creative technologist. I'm based in London. I work mainly for the performing arts industry, meaning I work mainly in theater, dance companies sometimes. I work with Arduino for the last 6 or 7 years, more or less, and I kind of self-taught, so I discovered by myself, how, the intricacy of this kind of wonderful world and all the different things you can do with it. Yeah, I think that's about it for now.
The session today, we're going to start off with a little bit about Nye's practice and how she's been using Arduino and some other platforms actually in her work. We're going to then go into a little section on Michele. Michele is going to tell us about some of the amazing projects that he's been using Arduino for. Then we're going to go on to a little introduction to the Arduino board itself and also a 101 project. So a very simple project that you can set up using Arduino. And then we'll go back to Nye, who's going to cover the bare conductive board, which is another board that uses the same kind of technology but has some really interesting functionality. And then we'll have a little brief talk about the Arduino ecosystem and community, so some of the other bits and pieces that you can plug into the Arduino board to do really exciting things. And then we've got a Q&A at the end, so we're not going to be able to take too many questions because we've got quite a lot to get through in 90 minutes, but we'll be doing a kind of a 10-minute Q&A at the end. So if you've got questions, please do put them in the chat and we'll try and get to those at the end as well. We've also got some email questions which we've tried to respond to as many of those in advance, but if there's any that we've missed, then hopefully we'll get to those at the end. So I'd love to invite Nye to take the floor first of all and tell us a little bit about what she's been doing with Arduino.
Thanks, Barra. So just a little bit more about me. So I was introduced myself. So I'm an artist turned software designer turned artist again. I originally trained as an artist and I spent 20 odd years in the software design industry and came back to art in about, say, 2013. And my practice tends to be around the sort of experimental software architectures, which is sort of exploring the ideas of where power is embedded in the network and sort of power of the gaze, power dynamics, and also the way that machines are starting to look at the world. And I've, over the last sort of couple of years, I've exhibited nationally and internationally, including Tate Modern, the Barbican, the Lowry, the V&A, and in fact, right now, I'm having a film screened at the Louvre, which obviously I'm bumping to be with you guys. And Vogue once called me the new Big Brother for reasons that you'll kind of see as we go through here. So just a little introduction to Arduino for those of you who are kind of coming to it anew. I know there's a sort of big mix of skill sets out here in the audience, but basically it's an open source electronics platform. It's a small hardware card that can be connected to components, and and a simple programming language to give it instructions. It's a microcontroller, basically, which means that it can read input, physical or from code, say, for example, from a proximity sensor or touch or sound, and it can turn it into output, which means that it makes something happen. For example, it activates a motor or plays a sound. The fact that it's open source means that there's a vast community developing and sharing their work, which is great for anybody starting to want to get involved in it, because there's an awful lot of people out there who will help you. It's designed to be easy to use and low cost, such as £20 roughly for an Arduino Uno. But it also fits into a broader ecosystem of quite affordable sort of hacker, maker, DIY electronics platforms that we'll talk about a little bit as well. But from a creative perspective, the kind of things that Arduino sort of facilitates, I want to talk very much about the sort of the sort of using Arduino as a tool and what it will facilitate. But the sort of things that it can do, you know, as a creative professional, it will give agency to inanimate objects, which is really interesting. You can translate between forms in a way. You can turn movement into light, you can turn touch into sound, you can turn data into images. It sort of allows all of these things in a sort of fairly sort of simple, low cost way. So you can create responsive environments. And it also has the kind of ability of bringing together disparate data and actions and things. So you can kind of weave together images, sound, behaviors, motions to create something completely new. And one of the kind of interesting things that it can do, particularly in a kind of lockdown context, is this sort of ability to transfer physical activity between locations, you know, which is an interesting thing to think about in a sort of socially distanced environment. But really sort of as a microcontroller and sort of different from things like a Raspberry Pi and things, I think what's sort of particular about it is it's very physical technology. It sort of enables quite very physical actions rather than just being something which is screen based. So I just want to tell you a little bit about how I started working with Arduino, and I started from totally a place of no experience, though I kind of worked in the software industry. I'm not a programmer or anything like that. And I started, this image is of my master's show where I was taking apart computers and using the components inside. Basically I would bring around these huge boxes of e-waste and make these sort of 3D drawings with them. And my first kind of exploration into electronics was that I actually got one of these fans to move again, one of these old fans. I was so pleased with myself. And somebody who came to the show, who was actually from RS Components, the big component supplier, he suggested that I might want to start to look at Arduino. So this was back in 2013, and he very kindly actually sent me a kit to play with. So I sort of followed through the tutorials and I wrote a few articles for their blog on it. Yeah, so that was that was my way in. I was just amazed at how I could, you know, do things which would impact on the world in that way. So I started to use it in my artwork, and this was the first time that I did it. So this was a piece I was commissioned to do called The Museum in the Shed Now, and it was about using technology to create a sense of local community. So I built a sort of series of exhibits using various tech platforms. And in fact, this one, in this piece, I also, and I think we'll talk a little bit about collaboration and community. With this piece that you can see here, I actually got a friend who I've met on one of these in a sort of Arduino community to actually help me with the coding and the engineering. So I didn't do all of this myself. that's one of the things I kind of want to talk about as well. You know, you don't need to do all of the coding. You can collaborate with people who are more technically savvy than you, and that's what I do. But this piece was it was a sort of remote piece called Decide, where basically I would ask a question every day and people could tweet their answer. And when they tweeted yes or no, you can see these little number counters would count their responses. And every time somebody tweeted within the gallery space, these little 3D printed canisters would rotate and they would drop a marble down the marble run. And so you could see that you could sort of, it was embodying the action in the space. And then the people who were tweeting remotely could also watch it over a little webcam. And you can see it happening here. I mean, it was 2014 test.
Yes, I do.
In fact, it was a Raspberry Pi. And then you can see the marble goes down and ends up in the bowl. So it was just a sort of a fun way of bringing that activity from another space into the space that we were in, into the gallery space. And then another exhibit I made, again, technically very, very simple. This was a piece about which consisted of objects with sound memories. So they were just objects that I picked up from the locale, and as I picked them up, I recorded a sound clip of their environment. So it was like they'd absorb the sound, and then people come along, and then if you touch the objects, they would play the sound. So here was another piece that I made in 2015, and this one I actually did code myself by with the help of various tutorials and sort of similar scripts that I found on the internet. But this was a piece called "Move for Me, Baby," and I had this idea of an internet of needy things, and basically it's a sculpture which it needs your attention. And it requires, you know, it wants to be looked at, and it will only light up when you're actually looking at it. So yeah, I thought it was just an interesting way to look at this. At the time, the sort of Internet of Things was really becoming a much bigger proposition, and people were starting to think and talk about it. And I was just very interested in this idea of all these objects that require your attention, that feed off sort of human intention and engagement. So this piece has a little proximity sensor in, and then when somebody's close, it actually lights up. You can see at the back, and I cast this plate in concrete, and I think it's actually using conductive paint to transfer it. You can see at the back, there's the Arduino, and then all the all the wiring. It wasn't a brilliant engineering job, I have to say, but I love the effect of the kind of the wiring and the way the cables make this kind of drawing. Yeah, and I just really like the idea of, you know, the idea of a sculpture that needs to be looked at. I'm very interested in the relationship between a piece of art and the viewer, and the sort of work that a piece of art does on the viewer, performs on the viewer. And you can see that soon. So this piece is called Backdoored, and it's a project that I was working on for a couple of years, 2016 to 2018. And this is the one where I got the name of being the new big brother. So I built a software system which was collecting and archiving surveillance images captured through compromised security cameras around the world. And I put together it's a huge archive, and I was really sort of obsessively looking at it. But in terms of actually turning it into an artwork, I wanted to make something to present these images, these sort of surveillance images, in a way that located the audience within the space, and sort of really made people think about their relationship to this sort of voyeuristic act of watching each other that we're all engaged with. So I staged this in a very kind of deliberate way. They built a sort of long dark corridor in the gallery, and which you had to enter through a small door, and I put carpet on the floor so that your footfall was softened as you came in. And then at the end of the corridor is this desk, which looks like somebody had sort of recently abandoned it. There was a bin with like rubbish in, and there were sort of old coffee cups and things lying around. And then on the wall, as you can see, is this sort of collection of images taken through these security cameras, all sort of driven through Raspberry Pi. And so I was very interested in that relationship between that sort of voyeuristic impulse and the sort of also sort of kind of repulsiveness of the images. And like you can see here very quickly, here's the space and walking away. In fact, I actually had outside, I had another security camera, which you'll see in a minute, which I presented as a sculpture, but was actually taking a live feed. So as people went into the space, they would actually see, because there was a slight time delay, they would actually see themselves on one of the images. So I became increasingly interested in the way that machines were starting to look at the world and engage with the visual world with sort of increasing agency in sort of intended and unintended ways. And I was also very interested in the way a lot of the surveillance imagery I had collected was of other machines. And I thought there was something very poetic about machines watching other machines. I became very interested in the idea of machine as audience, and I wanted to create an installation of machines performing for other machines. So this is a piece called Seekerbot, which was using, again, this is actually mainly Raspberry Pi, but I could equally have used Arduino to do it. And again, I collaborated with some technologists to actually do the software part of it. But these little bots we were projecting images, surveillance images on the world, and these little bots, as you'll hear in a minute, are actually analyzing what they see, and you'll hear them soon start to whisper about it. So they're actually describing the things that they see in the images. I hope you can hear that. And in fact, if you sort of get in their way and obstruct their view, they will start to describe you too. And talk about you. Mainly they talk about your clothes. They're very interested in clothes. But this idea of machine as audience was one that sort of really stayed with me. And then just because I'm conscious I'm over time now, so I've just got a couple of slides left. This is actually the piece which is now which is being shown in the Louvre right now. So this is called Uninvited, and it's a horror film for and by machines. And the premise is that it's a rogue, virally infected network of hardware, software, wetware, and machine learning algorithms, which have gained consciousness in a world that makes no sense. And it's a system which generates its own horror film. It's a combination of film and also these sort of software platform, and then these mechanical monster robots you can see moving up and down on the side. So they are watching the world through surveillance cameras and creating these horror films out of them, and also responding to them. And these are using Pis and Arduinos they run up and down these rails, as you'll see in a minute. one of the interesting things about this piece is it happened during lockdown. So what we actually did in the end is we actually installed the monsters in complete isolation, and just created a web interface where people could watch it remotely. So the monsters were moving here and also in a gallery in Romania, projecting and watching their films, and you could watch them over a sort of dedicated website. And then just a sort of a couple of final thoughts that I think about working with Arduino as a creative is just not to get too lost in the technology, and you need to really keep in mind the primacy of the storytelling. The technology doesn't need to be complex. You know, complexity doesn't mean better art. You can make something engaging and poetic with very simple technology. Don't get lost in the technology and its endless possibilities. I know this is a rabbit hole I've fallen down many times and regretted it. You need to maintain kind of some distance, because your core job really as a creative is to do your art. Thank you. Right. Yeah, sorry, a few minutes over, Barra. I do apologize.
That was perfect. Thank you very, very much, Nye. If you've got any questions for Nye about her work, do pop them in the chat now, and we will come to them just at the end. But thank you. That's amazing. And thank you for being here and not virtually at the Louvre. So thank you very, very much.
You're welcome.
So we're going to go straight on to Michele and learn a little bit about his work as well. Again, if there's any questions that come up about his the work that he's been doing, do pop them in the chat, and then we'll come and try to get answers for them at the end.
Great, thanks, Bara, and thanks, Nye, for that wonderful presentation. Nye mentioned the role of technologists that have been helping her in getting some of her works completed, especially in the technological side. And that's probably what somebody like me would do. I normally collaborate with artists or theater companies as opposed to creating my own art in a way. One of the interesting parts of the process is actually discussing with the artist what it is that they're trying to do, which in a way adds to the creativity of my role, but also it's interesting from an engineering point of view because it pushes me to find different creative solutions that sometimes help the artist to realize what it is that they want without compromising their creative process and their artistic ideas. To give you a few examples, I'm going to start sharing the screen, and I wanted to present a project I worked on for a company called Punch Drunk. Is a piece for children, and you'll see what it is about in the video, and then I'll explain a little bit more about it.
Circe's out there. We can't go out into the village to find the labours unseen. But I've been working on a way to get us out into the village safely. It's kind of like a spell, like a protection spell.
Who here plays games? Me. The game that I brought with me today has a character called Hercules. The game is a team game, but I don't want to tell you too much because I want you to test it for me and explore.
So that was based on, as you gathered, on the 12 labors of Hercules. And what's interesting about this project is that the kids started playing a video game in school, and then when they got to Punchdrank's warehouse, the actual village they've been playing in the video game was there in reality, built for them to explore. I don't know if you know this, some of the kids were holding some lanterns, and what I built for this system was a number of wireless receivers that were communicating with the theatrical system that was running the entire show. And they were receiving messages in order to give different signals to the kids. So the lanterns would be playing some kind of fire effect that was first normal, but then at certain times when some specific moments in the piece, the lanterns change colors to signal what was happening and guide the kids throughout the space. And that is something that can be done with not exactly an Arduino Uno, but there are loads of different boards that can be used that have different functionalities, like for instance, Wi-Fi capabilities. Let me change window. Another project I wanted to present is for a company called New Movement Collective. It's a pair of upper body exoskeletons that I designed and built for them. One of them is what we call the actuator, and the other one is what we call the follower. The follower is a mechanical structure that has pneumatic muscles built into it, which are basically some air tubes that can be controlled with compressed air. And as the air is pushed into the tubes and sucked out, they can compress and expand, and they exert a force onto mechanical pulleys that I was using to then control the actual human body of the person that was placed inside the follower. That's why it's called an exoskeleton. The other exoskeleton suit, the actuator, had some sensors on it, which could sense the rotation of the different joints around the shoulder and the joint on the elbow. And according to the movements that one of the dancers was performing, those movements would be sensed in real time and wirelessly transferred to the follower. So you can see some kind of puppeteer-puppet relationship between the two. I just wanted to show you a quick video of it. This was supposed to be performed at Southern Wells in April 2020, but was postponed because of lockdown, unfortunately. Yeah, unfortunately, you can't escape the messy wires. It's just something that keeps happening. The next one I wanted to show you is a company called Jean Bro Dance, and the piece is called Solo for Two. What I built for it was this little roving robot that we called Makiba. The robot essentially is a bit like a toy car that can move around on stage. It is controlled wirelessly during the show by myself, who I'm essentially driving it with a joypad, a bit like if I was playing a video game. It has a rotating platform on top of it, which has a birdie light and a mini projector. So the top platform is driven by a Raspberry Pi, especially the video side of it, whilst the motors that make the platform spin and the wheels are driven by Arduino boards. Again, there is Wi-Fi capabilities that has been added to the project so that I could wirelessly transfer the controls from my operating position. It was quite interesting, this project, because we spent quite a bit of time on the movements of the birdie light, which somehow resembles the head of the motor, its emotions. and we spent a bit of time trying to create a dialogue between Jean, that you can see, who you can see there on stage, and the robot. And it was obviously simulated because the robot was not acting, it's not an artificial intelligence. There's no machine learning going on there. I was driving it, but we found a set of movements and behaviors that was giving the impression the two had an emotional relationship. And it was, yeah, it was working quite well. I'm going to spend a couple more minutes talking about all the smaller projects I've worked on. This one is a project called Return to Elm House, Patricia Art Center. That piece of wood that you see there was basically a vibrating stick. The actors were using those sticks to direct the kids around the building during the show and tell them where they had to go, essentially. They were able to activate the vibration inside the wood remotely with an RFID system. So they could basically touch something not seen by the kids in their bag, and that would activate the vibration in the stick. And when they managed to do it properly, kids were amazed by it, because suddenly this piece of wood would start vibrating, signaling that they had to go in a specific direction. And I had quite a lot of fun doing it. The only problem with it was that once the sticks were closed, I couldn't get to the electronics anymore. So I had to be extremely careful not to make any mistakes that couldn't be rectified wirelessly. So I was still able to change the code and upload the code wirelessly on the boards, but I had to be very careful not to make breaking mistakes. At some point I did make one, and we had to open a couple of those sticks to get to the actual electronics inside, and then we had to close them again. And I'm sure the scenic painter wasn't so happy about it, but you know, we managed to get it back. This one is a project I worked on for the Mobile World Congress in 2019.
Michele, we're
Yeah.
still on the dance image for some reason. We're not quite.
Oh, sorry.
That's all right. I don't know
Okay.
whether it's sharing a specific tab rather than a.
Oh, sorry. Okay, let me just see whether I can rectify this. Okay, there you go. So, okay, now you should be able to see. So, yeah. Okay, so did you see the Makiba robot? Yeah, you're able to see that. Yeah. Okay, so you can see this is the stick I was talking about, the vibrating stick for the Backdoored Center show. You can see the kids holding it. And this one is the other one I was talking about. So this project was basically a version of the video game Pong. I don't know if you are familiar with it. It's the little ball that bounces across two little boards, and normally the two players would move the paddles with a keyboard, with keyboard strokes. But in this case, they had to pedal front and back in order to be able to move the paddle up and down the screen, so to try and play with the other player. It was quite a fun project. I don't know if you can see very well. At the back of the bicycle, you can see there's a 3D printed enclosure, and that's where I housed my electronics using an encoder, which is a bit of electronics that allows you to count how much you rotate it. It's essentially the same thing that is in your radio or in any kind of knob that allows you to maybe regulate the volume of something. So that was used to sense how fast the wheels of the bicycle were spinning and send that information back to the computers. Computer actually was only one, which was then running the video game and allowing the players to have an interaction. And I guess the last one I wanted to show is this one, which is exactly what it is. It's a fake bomb, which is exactly what it looks like, which I had to take on the tube at some point. And I was very close to be asked what it was by the officers. And luckily they didn't have to look into it, because I don't want to know how that would have gone down. But this is essentially a prop. It's a theater prop, so I didn't build a real bomb, and has a counter and has a keypad that people had to use to input a code in order to defuse the bomb and be able to open that little lid to the side where a key piece of information was hidden. It was part of a call it kind of escape room experience that was designed by a different company, and who asked me to build that. So yeah, I guess I think this might give you an idea of different kind of ways in which Arduino boards can be used together with what Nye has presented, and there's quite a lot there. You know, they're really versatile, and I keep saying Arduino, but most of the time, strictly speaking, I don't use a board that's branded as an Arduino. That's simply because the concept was possibly invented by the Arduino brand, but then the concept of miniaturized microcontroller board has exploded, and there are possibly thousands of different models that you can buy that do different things, have different capabilities, have different speeds as well. And yeah, I think that concludes my presentation for now.
Thank you very much both for sharing. I guess one of the things that we when we met, we were talking about this session was the idea that I guess theater makers are without their normal place to exhibit their theaters. And we can see that there's something incredibly theatrical about both of your work, and the interaction is very much at the heart of it. But if you were giving some advice to theater makers out there who are maybe thinking of using Arduino to start to experiment with how they could reconnect with audiences, are there any things that or ideas that you would point them towards at all?
What I would say is that Arduino, you should think of Arduino as kind of it's kind of like a pencil. It's a tool. You need to know a little bit about it, I think. But you shouldn't let it kind of guide what you're doing. But having said that, that kind of ability to pull in data from one location to another, to have something happening in one place and yet performed or displayed in another, is that kind of displacement, I think, is an idea that is, you know, very much works in the context of lockdown, where we have to kind of keep away from people.
So in its simplest form, an Arduino is kind of about having sensors that sense a movement or an audience member, and then having outputs that cause action to happen, maybe? Could you understand it in that way? Is that right?
Yeah, I mean, any kind of input, really, yeah, it could be the action of an audience member, it could be a sound, or you could be pulling input from other related, so input from other things and presenting them to the audience member in a new way. You could kind of do it either way, either taking the data from the audience member or just taking data from other sources, and sort of presenting them to the audience member. But I think, yeah, that idea of moving, I mean, obviously Arduino doesn't have to be moving across physical spaces. You know, it can be stuff that all happens in the same location, but that ability to use Arduino over a network, certainly, yeah, that seems very powerful in the current situation. Michele,
there was one project that you didn't speak about that was around this box that you made, that it kind of became a theatrical, an object which came at the theatrical event in itself, and as a piece of, I guess, COVID safe performance, it seems like a really interesting concept. Would you be able to share a little bit about that project?
This one, you mean, yeah?
Yes, the miniature museum.
Yes, absolutely. This was a lovely project designed for schools. So the way it works, Punch Drunk, they drop this cabinet in school, and is actually modeled from they take inspiration from the Horniman Museum in South London, some of the galleries there, and you can see it's a bit like a cabinet of curiosity. But what's particular about it is that that box that's in the center of it is called the Brogan box, and originally was called the Puka box, because essentially it's about this bird who materializes, this kind of entity that materializes as a bird and start causing havoc in the school, starts stealing things and starts start making things appear as well. And is all led by the teachers. So the teachers have a remote control that I've built with different buttons, and they can activate different parts of the museum at different times according to the narrative that they are developing. So is very much theater-led, teachers-led, and it doesn't require any actors in a way. The box can function as if it sounds like there's something ticking inside of it at certain times. The bell can be activated, can ring by itself. It's quite spooky, that one, actually. There are several LED strips inside the museum that can flash at different times, and the lid of the box can be closed by itself quite violently as well. And there is sound. There are 2 speakers embedded in the cabinet as well. So I guess that was one of the ways in which Punch Drunk was able to deliver something to a school and then let it happen without them having to be involved in it. And yeah, I guess you could think about it as some kind of also remote experience that can be organized to be somehow distanced as well. You don't necessarily have to, there are parts of it that can be experienced without touching anything. I mean, obviously this one, the kids were invited to explore it in groups and then discuss about it, and it fits their curricula. So there are lots of interesting things on the side that come with it as well.
So we've talked about some of the kind of amazing things that we can do with Arduino, from arts installations to interactive robots who describe us as they look at us, to kind of exoskeletons that can that move human beings by the dancers merely moving their body. So we've gone to the kind of really the heights of some of the most amazing things that can be achieved with this technology. But it would be really good to introduce the kind of very basic building blocks of what Arduino is. So I was wondering, Michele, whether you'd be able to just introduce the Arduino and the breadboard to the guys, for people who've not used the technology before.
Yes, absolutely. If you don't mind, I'd like to share an image from the Arduino website first, just to very quickly talk about what is physically in the Arduino Uno board. So if I go back here, so this image can be found on the Arduino website. It's available to everybody. I don't know if you can see the address up here. You should be able to see the URL. So this shows the fundamental blocks that are part of an Arduino board. And you can see, looking at it on the left side, the first block has these labels called ADC 0 to 5. Those are what is called analog to digital conversion, meaning they can sense an analog voltage in input. They can sense something like the voltage of a battery or all the kind of information that sensors often deliver, and that can be sensed by the Arduino itself. Right above that, there are some power pins. You can see GND, which stands for ground. When you apply power to something, there's always a negative and a positive, and ground's the negative side of that power. The plus 5 volts and plus 3V3 volt, which basically stands for 3.3 volts, are 2 power supplies that come from the Arduino, and that you can use to power other things like sensors that you connect to the Arduino itself. The VIN pin is instead to power the Arduino from an external source, but you can also use the barrel connector that is here, the DC barrel connector, or you can use the USB port that is also on the Arduino. And you can use any USB from your computer or anything else that delivers that 5 volts. On the other side of the Arduino, you can see a whole other set of pins, which are called, they begin with D. D stands for digital, essentially. And these pins are normally called Gpio, which stands for General Purpose I/O pin. And that's exactly what they are. They are pins that can be used both as an input and an output, according to how you configure them. And they're digital as opposed to analog. So they will be either on or off, or the input that they receive is either an on input or an off input. So you can start thinking about, oh, I want to connect a button to my Arduino. okay, you would use a digital input pin to sense whether that button is pressed or not pressed. Equally, you can use them as outputs to tell other things like motors or other interfaces, oh, I want you to do something. So you can program the logic in the Arduino to tell that motor to start spinning or to do other things, or that door to open, or any other kind of interaction that you want to create. Another very important thing to know about the Arduino is that it has 3 ways in which you can talk to various different sensors and interfaces. One is through the USB port, or the pins 0 and 1, which are labeled as TX and RX, and that's called the serial interface, or the UART interface, and that's just a protocol of communication. That's also how the Arduino communicates with your laptop when you plug it into it. 2 very important other protocol of communications, you can see them on the top right here. There are 2 pins labeled SCL and SDA, and they are part of it's called I2C interface. It's a protocol of communication that some sensors use. It's also sometimes referred to as 2-wire interface. The other one is down here, has got 4 pins called SCK, MISO, MOSI, and SS, and they are part of what is called SPI interface. And again, that is another protocol of communication that allows you to speak to different kind of sensors or readers, for instance, RFID readers, a bit like your Oyster card reader, and that kind of stuff. For people in London, I mean, obviously not everybody here knows what an RFID or what an Oyster card is, but you're possibly familiar with the concept of RFID. It's in your credit cards as well, and all that kind of stuff. So having said all of that, I'm going to jump right into the demo. So we're going to try and show you a very, very simple project today, done with an Arduino Uno board. What we're going to try and do today is just blink an LED, which is something that the Arduino can do very well and is fairly simple. So I'm gonna start sharing my screen again. Hopefully you'll be able to see this. So for those who are not familiar with it, this is the Arduino Ide. It's the interface that you use to program on Arduino. So you can download this from the Arduino website. It's available for Windows and Mac and maybe Linux as well, I think. But you can also use an online version of it. There's an online plugin that allows you to code straight from a web browser, and then allows you to put that code onto an Arduino straight from the browser, still using the USB port. So what I've done here, I've basically just created a new project, which opens up like this. It has these 2 blocks. One is called setup, and one is called loop. So setup is a set of instructions that you want to execute only once at the beginning when the Arduino first gets powered, and they only get executed once. And then the Arduino starts executing the loop section of your code, and all it does, it basically executes that code over and over again as fast as it can. So the first thing that we're gonna do, we are gonna declare an integer variable, which basically we're just storing a number, which I'm gonna call LED pin, and I'm gonna assign it a number, which is number 9. I'm doing this for convenience because I want to reuse this number 9 a number of times in my sketch. So I'm just gonna save it there. Then in my setup block, I'm gonna tell the Arduino that I want to use pin number 9 as an output. The way to do that is to call the pin mode function of the Arduino language. And the pin mode function takes 2 arguments. One is the number of the pin, and the second argument is whether I want it to be an input or an output. So here I'm going to reuse my variable. I'm going to say LED pin, and then I'm going to separate it with a comma, and I'm going to tell it that I want to use it as an output. And as you can see, the word output got highlighted automatically by the Arduino IDE. And that's because that's a reserved word that the Arduino IDE understands. And this could have been output, or could have been input, or could have been a couple of other things. But for now, let's just focus on the task at hand. So I'm going to call it output. And now the Arduino board knows that the digital pin number 9, which is down here, and I'll show you a little bit better later on, it's an output pin. And that's all I need to do for the setup. Then in the loop section, I want to then act onto that pin. So I first just declare it, I tell it what it is, and then I need to do something with it. The way the digital pins work is that they can either output 0 volts or they can output 5 volts in the case of this particular Arduino board. So we want to tell when to set that pin to 5 volts and when to set that pin to 0 volt. And this is what is going to drive our LED. So the function to do that is called digital bright. And I need to tell it what pin we want to use. And again, I'm going to reuse the same LED pin, which I saved before. And then I want to tell it to go high, which means please output 5 volts. Then I want to keep my LED on for a little bit of time. So I'm going to tell the Arduino board to wait. And that's the only way you can stop the Arduino board from keep doing that loop. You can tell it to delay. And I'm going to delay for 1,000 milliseconds, which in our case is 1 second. If you notice, every line has to be needs to have a semicolon at the end of it in order to be completed. If not, this would cause an error. So now I turn my LED on and I waited for 1 second. Now I want to turn my LED off. So I'm going to tell the Arduino board to set that pin low, which means 0 volts. So turn the LED off. And then I'm going to wait another 1,000 milliseconds. And that's all we need to do. If you want to write some comments in your code, you can do so by using 2 backslashes, one next to each other, sorry, front slashes. So this line will turn the pin on, 5 volts. This line will wait 1 second. Oops. This line will turn the LED off. And this line will wait for 1 second. So this basically is all the code we need to do that. And I can verify the code to make sure that I haven't made any mistakes. And the Arduino IDE will think about it, and then it will tell me that it has done compiling the code. That's essentially a translation from this code that I just written to the machine code that the Arduino needs to know about in order to execute all these tasks. And then to physically upload this code onto the board, I need to press the upload button here. But before doing that, I am going to go over to the Arduino bench and connect the components that I need to connect before I do that. So I've got a little LED here. I don't know if you can see it. It's a 5mm LED. This one is blue. You cannot tell because it's transparent, but when it will turn on, you will see there is a blue LED. And here I've got a Protoboard. A Protoboard is a very useful bit of equipment that allows me to plug things in and then use these very useful bits of wire that are called jumper wires that allow me to plug things into the socket of the Arduino board and into the Protoboard without having to solder anything. So they're a very useful prototyping tool because you can try things out, plug them in, unplug them without having to solder or desolder anything. So you can see there are 2 strips of holes here. These 2 are particularly the power lines. So all these holes on the red side are connected together, and all the holes on the blue side are also connected together. And this is supposed to be your kind of main power rail. So you would have a plus and a minus in order to power things, either from the Arduino or other things. The other side of the Protoboard, the breadboard, has these other strips, and the holes are all connected to each other these other ways. So they're also numbered. You can see here there's a 14, 15, 16, 17. So all these rows of holes are connected. Each row is all connected together. So The LED has has two connectors. You can see it's two metal legs, and one is longer and one is shorter. That means that one is the positive and one is the negative. So the shorter leg is the negative, and I'm going to make sure that I remember that I put it on the left side, looking at it from me. Now, what the LED needs is power, so we're going to give it 5 volts, and it needs ground, so we're going to connect it to ground as well. We connect the negative side of the LED to ground, and we connect the positive side of the LED to 5 volts. What we need to do as well is to put something that's called a current limiting resistor, which looks something like this. And that is because LEDs will basically blow up and damage your Arduino board if you don't limit the current they can draw from the board. That's due to how the LEDs work, meaning that they have a specific voltage called forward voltage, and that's when they will start lighting up. If you exceed that voltage, they will consume exponentially more power, and they will essentially explode. So as we don't want to do that right now, I'm going to insert these current limiting resistor, and I'm going to make sure that it connects on one side to the positive side of the LED, and to the other end, it connects to my 5 volts rail. Then what I am going to do, I'm going to connect the negative side of the LED with this black wire. I'm going to connect it to one of the ground pins on the Arduino board. Conveniently, there is one just here, which is labeled GND. So that's what I'm going to do, and that's the LED. That's the LED connected to ground. And then I'm going to connect the 5 volts or positive rail to pin number 9 on the Arduino board. And it's just this socket here. So I can just plug it in pin number 9. And now this should be my circuit completed. I don't know if you can see it very well. The wires are a bit in the way, but you should be able to see the Arduino board, the LED, the resistor, and the wires. So the next thing I'm going to do is to push that code onto the board. So I'm just going to press upload. It's going to compile the code again, and then it's telling me that there's a problem uploading it. So what I'm going to do, I'm going to check another very important part. Oh yeah. So the main thing that you need to do in order to set the IDE to work with your Arduino board is to set these two fields here. So you go into tools, and you need to tell the Arduino IDE which board you want to work with. So the Arduino Uno board is here on the Arduino AVR board, and I just need to select the Arduino Uno. And then we need to tell what USB port we want to work with. I am on a Mac computer, so the USB devices look, come up a bit like this with these kind of strange names. And I'm gonna have to use this one down here. If you're on Windows, you will probably see something that's called COM with a number. It could be COM 10, COM 15, whatever. When you plug the Arduino in, the system will assign a COM port to your Arduino. So once I've selected the port, then the IDE will know about it. And now I should be able to upload my sketch. There you go, that's it, it's uploading it, and that's done. And as you can see now, my LED is blinking for 1 second, then it's turned off for 1 second, and then it's turned on again, and over again. And it will keep doing this forever, basically. I can change this value. So for instance, I can make it blink much faster just by changing the delay time. And I can simply change, for instance, 1000 to 100 here in the code, and then upload the sketch again. And as soon as that's done, you will see it blinking much faster. And I think that's it.
That's brilliant. Thank you very much, Michele. Just before there is a question from somebody who's just about to leave, actually, for Nye, if that was okay. Nye, the question was, is there a particular coding or model or how-to for anyone who might want to use the hashtag interaction to cause action remotely? Is there a good place for people to find that?
You maybe referring to the Twitter?
Yes, yeah.
Right, okay. The way that worked is it was simply keying into Twitter API. So Twitter, along with lots of other social media platforms, makes an API available. Anybody can just sign up to it and actually pull out Twitter data. For example, hashtag, you can actually use, say, the Twitter API just to go in and say to Twitter, give me all of the tweets that are happening right now, which are hashtag Florida, and pull that in. Yeah, it's a fairly straightforward thing to do. You would just need to go to Twitter and just sign up for their for an API code. It's free, and they have sort of fairly decent tutorials.
If there's anything else to follow up, do drop it in the chat and we'll try and email you out a further response. So now you are going to show us a quick demo of another type of boards that you use in your work.
Yeah, absolutely. I mean, thanks for that brilliant demo, Michele. I'm going to show you really quickly another card which is part of the ecosystem and actually uses the Arduino IDE, but it's much more. Obviously, Arduino is, you can do so many different things with it. This card is much more dedicated, and as a result, I guess in a way it can be a lot simpler to use. So I'm going to show you something which actually requires no soldering and no coding, just the ability to rename a file. So this is, if you can see in my, can everybody see my the phone feed, my phone feed? This is a thing called a touch board. It's a little bit more expensive than Arduino, about £50, but it's specifically for turning touch and proximity into sound, or at least that's its main purpose, so you can extend it to do more sophisticated things. But it's a very kind of powerful, simple piece of technology. That's what I actually used for my objects with sound memories. So all you really need to do is you just power it on and plug it into a speaker. And if I could just share my other screen. So everything is contained on a little micro SD card, the operating system and any data, just like a Raspberry Pi. And if we can just go to, let me just share my screen for a second. This is the contents of the SD card, and this little card will play sounds when the sensors are touched. And the sounds, all you need to do is you need to just choose your sounds, these MP3 files, name them according to this naming convention, copy them onto this micro SD card, and then you can do things like, let me stop sharing. So here's the card. We've got our micro SD card in, and you can basically, these little sensors down the side, these little gold things, when they're touched, they trigger a sound, and you can just connect basically anything conductive to them. Let's connect one to pin 8, 1, 2, 6, 1, 2, 5, and 1, 2, this one. And then I'm going to connect all of these guys to just a conductive object. His jewelry, spoon, straw, cocktail straw, and a lemon. And then you have to just press reset to let it know that everything is reconnected. There's a little light flashes. You can see now when it stops flashing, if all goes well, you can see that when I touch these objects, it triggers one of the sounds that I've put on the card. So it's a simple thing, but you know, you can use it to perform quite effective interactions. In fact, I think this is actually, it's acting as a proximity sensor rather than a touch sensor, because I don't have to actually touch things directly, which I suppose is potentially useful in a COVID environment. But that, I mean, that is the basic way that it works. So you can kind of imagine there are any sort of creative ways that you could perform, you could transform proximity or touch into sounds, but you can also take this further. So this same system allows you to, oh, somebody's saying that it also work with, yeah, exactly. So it can work with proximity instead of just touch. So if you see here, there you are, I'm not actually touching the spoon, but it still triggers it. And I think you can fine tune the, obviously the sort of proximity sensitivity. And finally, you know, you can, this sort of interaction, as you can see, is super, super simple to set up. You can also, with just a tiny bit more effort, you can connect it to a computer so that touching something or coming close to something could trigger a video. You can also, because it's kind of very much dedicated for sound, you can use it as, you can connect it to a computer again and use it as a MIDI controller. So you can make a kind of a paper keyboard or other kind of some other remote sound input thing. You can set it up for an Arduino Ide. It's compatible, I think it's the Arduino Leonardo. So you can sort of layer more sophisticated interactions with it. And I think, you know, potentially very interesting. You can, though I've never tried this, you can actually use it with projection mapping to actually create an interactive wall or environment where stuff is happening and people can touch or be close to certain areas to trigger new sounds or videos. So yeah, I wanted to just show you this, just to show you that, you know, there's lots of really amazing, super powerful, sophisticated things, but there is also a kind of quite sort of straightforward way into this world, which doesn't require a lot of technical expertise.
There is a question about what the name of the board is.
It's called the Touch Board, and it's made by a London-based company called Bear Conductive, who also make like a conductive paint, which they kind of promote very much with this. But it's on the, I guess this is probably one of the things that we'll be sharing afterwards, a link of a list of sort of useful links.
Brilliant. Thank you very much. Thanks very much for that. There's been a little bit of a chat or a conversation in the chat about something that we're just about to move on to now. It was something that I said at the very beginning. I said the Arduino board, when of course it's a whole ecosystem of different different people using the technology in different ways, different people who are manufacturing it, because it's an open source technology. I guess could you and Michele talk us a bit about both the ecosystem in terms of the kit that you can buy to work with Arduino, but also the ecosystem in terms of different communities and hack spaces and things like that.
Yes.
Oh, yeah.
You go first, Michele.
Very quickly, I'm going to show you a couple of boards, and then you can probably talk about the community aspect, which you know more about. I just wanted to mention, as Bara said, so the Arduino ecosystem is quite developed. There are lots of different kinds of boards. I'm putting them in the Arduino bench camera, so maybe they're easier to see there. So this one is an Arduino Mega. Is as you can see, quite a bit larger than an Arduino Uno, but the main difference is that has a lot more digital pins and a few more interfaces. So it's got more serial ports, but it's got 54 digital pins, I think. So if you've got lots of things to drive, this could be one of the options for you. In terms of the wireless stuff that I talked about at the beginning, the project with Punch Trunk, I was using a version of this little board here, which actually you can see is a lot smaller than an Arduino Uno, and this could be a very good advantage in some projects where you don't have much space. This one is based on a chip called ESP8266, and this one in particular is made by a manufacturer called Wemos, and this model is the D1 Mini. I don't know if you can see it down here. But yeah, if you Google either Wemos or Lolin D1 Mini, you should be able to see it. This one is exactly the same board, but is made by a different manufacturer and therefore has a slightly different shape. But they all do exactly the same thing. They have digital pins like the Arduino does, but the advantage is that they can also talk to a Wi-Fi router, and they can perform operations on the network. So they can talk to a web server, they can become a web server, and they can do all sorts of other Wi-Fi related things. Another one that's worth mentioning is the Teensy board. This one is a hugely powerful microcontroller for quite a lot with a much smaller format. It runs a lot faster than an Arduino and has a lot more pins and can do quite a few more things actually in one single board, and that's interesting to know about. This one is the Teensy 3.6. Its bigger brother has an SD card socket in it as well. And yeah, that's it. I guess I would show you the Raspberry Pi as well for those who are not familiar with it, which is, as you can see, quite a lot bigger than a Teensy board, but roughly the size of an Arduino Uno, although is a fully developed computer as opposed to a microcontroller.
This little gadget that I retrieved from my studio, just to say, when you have your Arduino, you can also get shields, sort of extra cards that layer on top, which extend the functionality. So I think a regular Arduino wouldn't normally be able to power that many LEDs, but this is a LOL shield, which is specifically dedicated to powering larger numbers of LEDs. And so I bought that to make this little sort of screen animation. But it's just a sort of example of the sort of extensibility of the platform. But yeah, the thing I really wanted to talk about is the community. I mean, because all of this is open source, and I guess, you know, it's so widely used. Obviously, there's a huge community online of people publishing their projects on YouTube. They usually publish the code as well, so you can take the code and you can adapt it. So there's a huge, you know, anything you can think of that you want to do with the Arduino, somebody has probably already tried to do something similar, and has usually shared the code. So, you know, you're really sort of starting from scratch. But another thing that I found really helpful, particularly sort of earlier on is Meetup Groups. So a lot of the people I collaborated with in the first place, I found through Arduino Meetup Groups. Basically, you're just sort of social groups where you go along, and it'd be a mixture perhaps of creators. So probably, certainly when I was going, probably heavier on people from a more of an engineering background. And you would just go along and kind of share your projects and ask questions. And I certainly found that there were a lot of very kind of technically able people there who were both really interested in people who were actually doing creative projects, and really, really eager to and generous to share their time and expertise. So I would totally recommend that to anybody who wanted to get started. You know, you can go along from a really simple perspective, you know, sort of early stage, and talk to people about what you want to do. And there will be people there who will have ideas and will be able to help you. And there are these meetups all over the place. Obviously, there's a load in London. There's at least one in Bath that I found earlier. And sort of more, you know, which are Arduino, but also sort of more general Raspberry Pi, the whole sort of hacker, maker, hobbyist community. Yeah, so that's a really powerful part of the technology, is the sort of the people and all the work that they invest and share in it. So, you know, it's something which really makes it much easier for anybody to get into that space.
Brilliant. Thank you very, very much. So we've got a little time for just a couple of questions from you guys. If there was anything that you wanted to ask, then pop it in the chat. I'm going to kick off with a question that was emailed in by George, who I believe is here today.
Hello.
Hello. We believe that you're making a fire installation with solenoids and Arduinos. Is that right?
Yes, that's yeah, I am.
So would you be able to tell us or describe the project that you're creating using Arduino? Would that be?
Yeah, so it's sort of it's based around sort of like the human sort of body, and this section that I'm sort of trying to do is about like it's about like neurons firing in your head and stuff. So the idea is sort of firing flames at a very specific, like we only need small amounts of gas. So it's not like just lighting great big fireballs or anything like that. And they're very intermittent. And what I've been struggling with is basically telling it to go turn solenoid on for 2 seconds. After 2 seconds, sparker, and then wait, and then that I want to keep that as a sort of event and put that at random time intervals. At the moment, I can only figure out how to make it happen every 5 seconds. Well, you know, like, you know, repeated time intervals, whereas I want to be able to put them very random, if that makes sense.
Brilliant. I don't know whether Michele, is this something you can answer now, or is it something that takes a bit longer?
Yeah, I mean, it will probably need a little bit more of a larger conversation, but the first thing that comes to mind is that the Arduino IDE has a random function, which is able to generate a random number within a certain range that you give it. So for instance, you could say random 1,000, and it would generate a number between 1 and 1,000 every time, between 0 and 1,000, I think, every time you call that function. So you could think of using the delay function that we showed into the LED blink sketch on, but applying a waiting time that is random. So every time that delay function gets called, the amount of seconds or milliseconds it waits for, it's dictated by the random function, if that makes sense.
Yeah, that'd be cool.
And you could think of building specific sub-functions that get called at specific times in your loop sketch. Again, managing it with different delays. That's something that comes to mind.
Brilliant, thank you.
There's a question from Lewis about how is it that Arduino can interface with DMX, or can it interface with DMX?
I would say get a DMX shield. That's something that Nye mentioned earlier, that there are shields that you can get specifically that have different functionalities that the Arduino board itself doesn't have. DMX in particular require a specific external chip. If you look on the SparkFun website, they specifically have a DMX shield that is not for the Arduino itself, it's for another board called ASP32. But there is a specific DMX board that you can look at.
Brilliant. Thank you very, very much.
There's also on the Arduino website, sorry, there is a DMX example, but it's a bit more complicated because it requires you to do quite a bit of wiring. But if you look on the Arduino, I think it's called Arduino Playground, there are a number of sample projects you can look at, and I think one of them uses DMX, but the pre-made shield is probably a lot easier to start with.
Right. There is a question from Jiz who said she was asking about how you power external devices like solenoids that need a higher power than the actual Arduino can supply itself. So how does that happen or work?
Yeah, from a technical point of view, you would use the Arduino as a driver for a different system that takes that input from the Arduino, but then is able to drive solenoids and motors and stuff like that. So for motors, for instance, an example is to buy an external motor driver board. There are plenty of those, especially for DC motors. And then you would just get a motor driver board that works with the kind of specification for your motor. The Arduino would normally use a function called PWM, which is used for on some of its digital pins, and that helps ramping up the speed of the motor through the motor driver. So if you tell the motor driver, go at this specific speed, but it's the Arduino that tells the motor driver to do that. For solenoids specifically, you would have to put either a solenoid controller, but the simplest way is called a transistor or MOSFET. It's a little integrated circuit that again takes a signal from the Arduino and tells its own gate, is called, to open or close. So the MOSFET would handle the higher power coming from a bigger power supply for your solenoid, and the Arduino would tell the MOSFET to open and close whenever you want to do it. And that is what will physically drive the solenoid with the higher power supply. That's essentially how it works. You can look at, there's a very, I'll see if I can find it. There's a very good builder tutorial. I'll see if I can dig it up and put it in the chat, specifically on how to do that.
Great. So we've got two more little questions, I think, and then we'll probably wrap up for today. But there's one question around, are there possibilities of integrating sensor sound elements in soft textiles that aren't touched or isn't touched? I know that you were speaking about a larger conductor. Could you give me an example of what this would look like? Would it be a metal pole or something like that?
I suppose you could use proximity to a certain extent. I don't know how far that would reasonably take you, or how far away you could get. You could maybe you could have light sensor. So you could have some kind of light receptor sensor in your, you know, within your wearables. Yeah, or sound. Couldn't you could have something which would pick up volume vibrations, I would have thought.
Yeah, you could also potentially use proximity sensors in terms of range. So there are some tiny sensors that can sense how far away something is, and they can go from, say, 10 centimeters or less to maybe 3 or 4 meters. And you can have that range measured by the Arduino if that's something that you want to play with. I used that to trigger sound on an artist's sculpture. Actually, she wanted people to be able to trigger sound, different sounds according to how close they were to the sculpture itself. So you could think of mounting that on somebody's body as well.
There was another question from Lewis. Lewis.
Yeah, so what kind of jump would it be from programming Arduino to using programmable logic controllers and bigger stuff, really?
Yeah, I guess it depends what you mean by bigger stuff.
Yeah, programming a sort of different sequences where you might need sort of safety features and e-stops and that kind of thing. So something where you want a slightly more reliable system.
Sure. There are two ways in which you can do that, in my opinion. One is you can build that safety electronics into your project, so you can add layers of safety at different stages. So you can think of having that controlled by an Arduino, and that is one way of approaching it. For instance, for the exoskeleton project, we have an electronic valve, and we would tell it to open in case of emergency, to release the air from the compressor in case of emergency. We also had a safety button that the user could press or depress, so, you know, that kind of that man switch kind of thing. In that case, that would also open the electronic valve and it would release the air, releasing the pressure. But also we had a manual switch that would physically cut the power to the compressor in order to achieve that in case there was an electrical fault that would, you know, prevent the electronic valve to open. At the same time, if you look for industrial versions of Arduinos, there are a lot of boards that are on the market. They are more expensive, but they meet higher standards for safety, and they've got loads of electronics built around them in terms of safety and stuff like that. Or you can use something called a PLC, which is an industrial Arduino board as well. Siemens make them. There are different models, but they are programmed slightly differently.
Awesome, thank you. That's good to know.
No worries.
There's one last one has come through. They were just asking about higher external power to a motor or board. Is there any issues about bypassing board protection? Can it come back to board and blow it?
You have to be very careful with what you do. You just have to make sure that the higher voltage or current is routed correctly in your circuit. If you plug more than 12 volts into an Arduino, you are gonna fry it. There's no matter. There's no question about it. If you plug your plus and minus of your power supply into the wrong sockets of the Arduino, you could fry it. In a way, it's good to start experimenting with inexpensive boards, meaning that if you do fry it, it's not a huge loss. But yes, it is possible. When you use higher power loads, it's absolutely possible that you could inadvertently fry part of the circuitry. So be very careful.
Yeah, thank you very, very much. Thank you very much, Nye and Michele, for today. It's been amazing to see the breadth of work that you've been creating, and thank you for being so generous with answering questions today as well, and over the last little while on our Discord. If you have any other questions, please do join us on our Discord. We can't guarantee that Michele will be there to answer them, but hopefully as a community we can work together to find answers online. So do join the Discord. It's there as a community of people using digital technologies to create live work. So hopefully we'll be able to help each other through our various adventures in that field. We've also put a feedback form in the chat as well. So please do give us some feedback on today's session. We are programming more sessions in the coming months, so it'd be great to hear if there are other technologies that you guys want to know about or learn about, so we can run sessions on that will help you in your creative practice. But thank you so much for coming today. It's great to have so many of you here, and thanks again to Nye and Michele for everything today. But thank you very much for coming, and see you all again soon.